Get one of these days. Not today. Okay. What happened? Did it go away? No, it's still there. Okay. Weird. Usually it just makes a little box down there. Anyways, where was I? I was here. It's been a whole week. Hope you enjoyed a little break on Tuesday. We've got kind of some lofty goals for today. We're going to finish 2.1, and then I want to do 2.2, which is kind of more of the same, just graphs of linear functions. And then 2.3, I will let you do on your own because it's just more problems. And so just solving more problems. So I'll post the solutions to the examples and then kind of try the assignment, see how it goes. But I also have 2.4 as complete on your own, which I kind of want to do together, but probably next week, because we won't have time today. Which brings me to the next problem. Not a problem, just I don't know. So if we do 2.4 and 2.5, I'm actually happy to not have material that's not on the test before the test. I don't like doing that. And so I'm fine to kind of bump 3.1 down and just wrap up chapter 2 next week. And then we've got Thanksgiving. I hope you have plans and fun weekend plans. But then I scheduled the test on the Tuesday right after. Oh, so rude. Now, I'm open to moving it to the Thursday. Of course, then again, we'd have to cover some material that obviously won't be on the test, right? We kind of have to get cracking on chapter 3 if we move it to the Thursday. But you can kind of see where you're at. I know there's that chemistry test as well on the 14th. So I don't want to overload you. It's an option, but you just have to let me know kind of as a group what you want to do. I'm getting no, everyone's like, I'll see what everyone else wants to do. That's all right. You can put it in your secret chat. So we can move it to the Thursday, totally fine by me. I just need to know by the end of next week. I don't know. That might be nice when we're doing a test and when we're doing material. Okay, and last thing I wanted to mention is I did post chapter 1 review problems. Okay, this is only for practice, it's not for marks. So if you've done those assignments and you feel like, okay, maybe I need to just kind of see the chapter 1 problems kind of all, because I do find that when it's broken up by section, right, that kind of guides you, and that's good for practice, kind of initial practice. But then I'm pretty sure the chapter 1 review problems are jumbled, or at least they'll feel jumbled, right? Which is kind of, I like to move chronologically on the test as well, so not too big of a problem if it's in order, but just more problems, but they're not for marks, so you can just try it. And there is a due date, but it's right before test 1 was originally scheduled, but and then it's open for practice afterwards, so it doesn't really matter. Okay, good. Anything else I need to say? Any questions, comments, concerns? No, nothing. Okay. Tiny bit of review, just what we'll need today, which is the rate of change, which for a linear function is the slope of the line. Where's my pointer? Here. Okay, so the rate of change we've calculated in the past. I can't remember what section, but that's okay. And so, but for a linear function, which means we have a straight line, okay, then it's going to be our slope. And we've got a couple of different options, right? Rise over run if you want to, the change in y over the change in x, or delta y, delta x, okay? Or y2 minus y1 over x2 minus x1. These are all variations that we've used. Or finally, if we want to use function notation, f of x2 minus f of x1 over x2 minus x1. Okay? And so, and I kind of cheated and made a little note, because today what we'll do is we're going to find linear equations, right? So given some information, can we construct a line? Okay? And so to find a linear equation, which is y equals mx plus b, we follow these steps. Sometimes we have the slope and sometimes we don't, right? But in general, the first step is you find the slope, which is your m. Then the next step is you use a given point on the line to solve for the y-intercept, right, b. Now, what did we say last day? We introduced the interpretation of the slope. The interpretation of the slope was for each unit increase in x, right, we'll see a slope increase in y. Right? So for each unit increase in x, we will see a slope increase in y. Okay. That one's fine. Not really one we're going to be attached to today. We're more attached to the intercept, but it would be weird if I only introduced one of them, right? Or reviewed one of them. So the intercept, right, b, is where it crosses the y-axis, right? And so that means that x has to be 0 at the y-axis. And so here, this is the value of y when x is 0. I'm going to highlight the things that we latch onto in terms of these interpretations. Okay, so for the slope, we talk about for each unit increase in x, right? If I go from 1 to 2, right, what happens to my y? Right, that's the slope. Whereas here, for the intercept, right, we latch on to, okay, well, what's our y when x is 0? So they both have to do with x, but in different ways. And so today we're going to find linear equations, constructing lines, right? First, you find the slope. Sometimes you have it, sometimes you don't. Sometimes you have to work a little bit for it. And so we'll see a couple of different examples. And then we use a given point on the line to solve for the y-intercept. Because we also know that x has to be 0, really, b must be at 0, b. So there are instances where you're given the y-intercept, right, just as one of the points, right? And so that's nice to keep track of. But just in general, we just use a point on the line to solve for b. So what does that look like? Well, pick up here next Thursday. Well, here we are. Time flies. A little bit of there. Find the linear equation that passes through these 2 points. And just to highlight, right, find the linear equation means find y equals mx plus b. Has to pass through these 2 points. What's nice about lines, right, is you only need 2 points. And then all the other points will behave the same, right? And so that goes for drawing lines as well, right? You only need to plot 2 points on the line and then extend the line, and you're done. Okay, so going back to our steps, we're going to find the slope. I don't see the slope given to me, so I'm going to have to calculate it. Okay? I've got 2 points, and we know how to do this. Right? I'll do y2 minus y1 over x2 minus x1. And let me keep this just on the sort of same page. Oh, it's going to look wonky. Anyways, that's okay. I can't help it. 0.1, 0.2. But if you're kind of nifty, you could use this as 0.2 and this is 0.1, and then you can read them just straight out. Either way, you'll find the same answer, 9 minus 3 divided by 3 minus 0. So I get a slope of 6 over 3, which I'm going to go for 2. And I need to bump these down. Or maybe, instead of bumping it down, hey, what happened? I'll bump this up. Bump it up. There. So we've got our slope, 2, which means for each unit increase in x, I expect to see a 2-unit increase in y. Well, now, what's step 2? Step 2 is use a given point. Now, you can use either of these points, right? One's going to be easier than the other, right? But it doesn't matter. Just pick one and solve for b. So what does that look like? So use a given point. Right? We were given 0, 3 is on the line, or 3, 9. Why do I say one is easier than the other? Right? 0, 3 is the y-intercept. Right? So of course, if this was on a test, you would probably pick 0, 3. But because I want to show you that you'll get the same answer either way, I'm going to use, so I will use this to illustrate this point to illustrate, right? This is the y-intercept. So even if you're not given the y-intercept, right, we'll still know how to solve it. So what does this look like? Well, we're told that when x is 3, y is 9. Right? We also know that the slope is 2. So if we start here, y equals mx plus b, let's clean up that b, it looks the same. Oh well. Right? We're told that, okay, y is 9, m is 2, and x is 3. And the only thing that I haven't solved for, or that I'm solving for, is the b. Right? So I get 9 equals 6 plus b, which means b must be 9 minus 6, which is 3. Right? Luckily, that matches what we saw here. Right? That just confirms it. Right? This confirms 0, 3. Right? So now we can construct the line, therefore y equals, so now we keep our y and our x's open for an input of x, and then we solve for the output of y, or potentially, right, we can put in a y and solve for x, right? But we keep the x's and y's open and y equals mx plus b, so y equals 2x plus 3 is our line. Nice. Find the slope, use the point, solve for b, and then put it together. Let's do another one. Wait. I did correct this, but it's not clear. Yeah. Just to show you, so A looks the same as before, right? But that's okay. Do it for practice. B, the information looks just slightly different, right? But we've also already found the slope with information like this in function notation, right? And so that's okay. We know what to do. And we still have xy coordinates, right, in B, right? When x is 2, y is 3. When x is 4, y is 7, right? So just slightly different. Let's do A first. First, we want to find the slope. The slope, because I have 2 points, I'll use y2 minus y1 over x2 minus x1. Right? For B, I anticipate using f of x2 minus f of x1 divided by x2 minus x1. Or if you want to write them as y's, that's okay too. So just slightly different. M is going to be 0 minus 3 divided by 4 minus negative 2. I get negative 3 over 4 plus 2. I get negative 2, 3. Okay. What was I doing? Just making sure that the negative slope made sense. Right? You can plot these. Negative 2, 3. Let's see here. If x is negative 2, y is 3. That's a point, your first point. And then if x is 4, y is 0. That's your second point. So I do expect my line. I'll try to move my line down. So I do expect a negative slope. Because this is heading down, right? And so this is a negative slope, which makes sense because I got negative 3 over 6. Good. If you want to reduce it, you're welcome to, right? I'm pretty sure your calculator, depending on your setting, right? If you do negative 3 over 6, mine just changes it to negative 1/2. That's okay. Either way, the number is the same, right? And so I'm not too concerned about the reduced fraction, right? Negative 1/2. If you want to use negative 1/2, that works too, of course. But I'm not going to reduce it. I will leave it as is. You'll get the same answer. I just find it's a little bit confusing when all of a sudden I have a reduced fraction, maybe. Okay, so we've got the slope, -3/6 or -1/2, however you want to, whatever you want to call it. Now we're going to use a point on the line. Now, if I glance up here, I don't have a convenient point, right? I'm not given the y-intercept, so it doesn't matter which one I use. Okay. I'll just use the first point, right? Kind of flex our math with a negative in there, maybe. Might be nice. So here, in y equals mx plus b, when x is -2, y is 3. Y is 3, m is -3/6. Sorry, what was 2? -2 times -2 plus b. Now, when you're working with fractions, I encourage you to check with a calculator, right? But technically, -2 is really -2/1, right? So I can still rewrite this as a fraction times a fraction. Do you remember how fractions multiply? You can just go straight across, right? And so here I get -3 times -2/6 times 1. Let's start there. So I get 3 is -3 times -2. Look at this. 6/6 plus b. 6/6 is 1. So I get 3 must be 1 plus b. Solving for b then, get 2. I didn't do a very good sketch, but it helps to visualize what this line should look like, right? Because here I can see that it should be less than 3, right? I didn't do myself any favors, but all I can really tell is that it should be less than 3, right? Which it is. So I'm happy, right? But it also looks like it should be positive, right? Because we don't cross y equals 0 until x equals 4. Right? So I guess we know it's somewhere between 0 and 3, which it is. So I'm happy. Therefore, y must be -3/6x plus 2. Or -1/2, if you prefer. Yeah. Good. Nice. How about this next one for a new version of calculating the slope? You're more than welcome to rewrite this as a point if you prefer to read it like that, right? What would this point look like? Well, when x is 2, y is 3. And when x is 4, whoops, y is 7. So we still have a point. I'll use the function notation just for practice. But I need to add a page here. Whoa. So again, our first step is to find the slope. And like I said, I'm going to use the function notation version over x2 minus x1. F of x2 minus f of x1 over x2 minus x1. F of x2 is 7. F of x1, if I do them 0.1, 0.2, f of x1 is 3 divided by x2, which is 4, minus x1, which is 2. So I get 4 divided by 2, which is going to go for 2. What you'll notice is if nothing is changing on one side of an equal sign, I tend to leave it open. I've been trying to fill in the M, right? But if nothing is changing, right, you're allowed to just leave it blank. Right? And then I like to reintroduce it at the end, just so you don't have to scan all the way up. Nice. So we got a slope of 2. And now you can use either of these points. I tend to just pick the first one. Kind of eliminates any effort. So in y equals mx plus b, when x is 2, y is 3. 2 times 2 plus b, let me confirm. X is 2, y is 3, and the slope is 2. So I get 3 is 4 plus b. Which means b must be 3 minus 4, -1. Nice. Therefore, I'll just punch it here. Y is 2x minus 1. If you have a graph, right, I can give you a function as a graph, then, right, as long as you remember, okay, I need 2 points, you'll always just need 2 points, right? Or if you have the graph, what might you be tempted to do, knowing that the first step is to find the slope, right? You could go back to your roots, rise over run, right? And that is what we're going to do, right? But really what I'm going to be looking for, and what you would be looking for, are just 2 points that you feel confident in reading off of the line, right? And so, for example, if I use x equals 2, I don't feel very good about saying what y might be, right? I can guess 0.8, maybe 0.75-ish, right? But pick something like maybe here is good. How about here? Here. Those are all kind of readable points. Right? Make your life easier. So here we have 3 points that we could choose from, right? But we only need 2. What's this point? This point here is when x is -2, then y is -2, -2, -2. When x is 1, y is -1. And when x is 4, y is 0. So here we have 3 points that we could choose from. Let's use these 2 points. We can use Any 2 points, we will use 1, -1, and or 0. You can try it with -2, but I don't like negatives, so yeah. Our slope is 0 minus, oh, bad, Emily. You should always write your empty equation first. Right. Show me what you're about to do. Just gets really boring because we've done it so many times already. We kind of know what we're doing. But then I can put in 0 minus -1 divided by 4 minus 1. I get a slope of 0 plus 1 over 3. Which, if you mapped it back, right, and you looked at the rise over run, right, it does look like the rise is 1 and the run is 3. So you would get there either way. Okay, now we have to find the y-intercept. Let's use the first point. So in y equals mx plus b, if y is -1, mixing things up here, m is 1 over 3 times negative, nope, times 1 plus b, then I get -1 is 1 over 3 plus b. Fractions. You can use your calculator, right? But let's review how we work with fractions, right? So multiplying fractions, you can just multiply across in the numerator and multiply across in the denominator, right? Well, when we're adding or subtracting fractions, right, then we need a common denominator, right? So first thing I'm going to do is just rearrange this and solve for b, and then work with the fraction. So I get b must be -1 minus 1 over 3. To add or subtract fractions, we need a common denominator. And there are fancy ways of doing it, right, which you've probably worked with in the past, kind of the lowest common denominator, blah, 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 blah. Because I don't care about things being in reduced form, right, I like things that will just always work. Okay? So what I do is I'm going to force a common denominator of 3. Okay? How can I do that? Well, as long as I multiply -1 by 1, technically, I'm not changing anything, right? And so then what I do is, well, what I need to do is give myself just a little bit more space here. If I multiply this by 3 over 3, 3 over 3 is 1. Right? -1 times 1 is just -1. So I haven't changed anything here. But what have I done? I've turned my -1 into -3 over 3. Right? Now I have this common denominator of 3. So now I get -3 over 3 minus 1 over 3. So now that I have that common denominator, it just stays common, and I can add or subtract in the numerator. And so here, what this becomes is -3 minus 1 all divided by 3. And I'll bump these guys down. -3 minus 1, I get -4. And then over. I want you to try it on your calculator, though. If you skip doing the common denominator, if you just put -1 minus 1 over 3, making sure the 1 over 3 is just in brackets, or it depends on your display. Sometimes it'll show it as a fraction. So if you go -1 minus, and I like to use brackets, bracket 1 over 3, I get -4 over 3. Right? And so if you're not comfortable working with fractions yet, that's okay. Right? You can always check it on your calculator. So we get -4 over 3, which is not a nice number, -1.33333. So I'm just going to leave it as a fraction. So therefore, y equals 1 over 3 x minus 4 over 3. Nice. Since we have the graph, and we know the y-intercept should be -1.333, we can kind of zoom in here, and that looks like a reasonable y-intercept that we found. So it looks good. Okay. Everyone's favorite thing, word problems. Any questions about that one, though? Fractions. We've seen this before, kind of the same scenario, right? Where in the word problem, right, there are 2 points hidden, right? And so we need to kind of dig out those points, and then we can find our linear equation. And so at age 20, the maximum target heart rate when exercising is 170 beats per minute. Well, at age 70, the max target heart rate is 128 beats per minute. If the target heart rate decreases linearly, right, so it follows a straight line with age, now how you read this is if it decreases with age, then x will be our age. That's subtle. But if you think about, so then we have to write an equation relating them. But if you think about, okay, what's a reasonable input versus output in this function, right? If I put in an age, I get an output of the maximum heart rate, or the target heart rate. Okay. Whereas you could say, okay, if I give you a heart rate, right, then map it back to an age, but it's not as obvious. And so we're going to use age as our input, x. And then see what we've got. So we're given 2 points here. They're kind of hidden, which is why word problems are hard. Right? Still get the same information, but you have to kind of dig for it a little bit. So if x is age, then if x is 20, we're told that the output should be 170. And if the age is 70, then the output should be 128. And you can write those in function notation if you prefer, but I like to just boil it down to 2 points, 2 coordinates. Well, that's the hard part. Then we're on easy street. Now we're back to finding the slope, finding the intercept, and then we're done. So, we're going to find the slope, y2 minus y1 over x2 minus x1. I have 128 minus 170 over 70 minus 20. I need a calculator for this one. 128 minus 170 is negative 42. 50. Doesn't feel like that's going to be anything nice. Here's a question. So it does reduce into a nice decimal, just negative 0.84. No repeating, it doesn't continue. All right, so then it's tempting to just use the decimal, which we're allowed to do. Right? So, or negative 0.84. And the reason that I'm saying we can do that now is because it is just negative 0.84. I'm not rounding anything. That just is the number, right? If you find yourself rounding values, right, then I would think twice about using the decimal version. But if you're not rounding anything, right, then you're allowed to just use the decimal. So I'll write that here. So since negative 42 over 50 is equal to negative 0.84 without rounding, we can safely use the decimal. I think I prefer to use the decimal in this case because negative 42 over 50 is kind of nasty. So, but you can try it with the fraction if you want to, but step 2 is still to find the y-intercept. So in y equals mx plus b, I'll use the first point as always. X is 20, y is 170. 170 is negative 0.84 times 20 plus b. Negative 0.84 times 20 still gives me a nice number. So I get, how about I pull a fast one here? B must be 170, doing the switcheroo as well as the addition to 170. B must be 170 plus 16.8, which is negative 0.84 times 20. And then I have to subtract it, but subtracting a negative makes a positive on the other side. I did two things in that line. 170 plus 16.8 186.8. So now, therefore, y is negative 0.84x plus 186.8. If you ever feel like you want to check your work, we found this intercept with the first point, and so it's kind of circular logic if you use the first point again, but you should get back to the same answer. But what if we plug in the second point of x equals 70, and then we can confirm that the result is y equals 128, right? Because we know it should be. So here, what we can do is we can check at 70, 128. So if I plug in x equals 70 here, let's try that. Especially when we have these kind of non-clean numbers, negative 0.84 times 70, then plus 186.8. Phew, we get 128. So that's good. So I'll just put that here. Does it equal negative 0.84 times 70 plus 186.8? Does it equal 128? It does. So you can check your work, which is nice. The Fahrenheit Celsius conversion. It's a nice linear equation, and so it tends to come up often. Okay. Well, any questions about this one? Last one. Again, we're given 2 points that are on this line. Water boils at 212 degrees Fahrenheit, which is 100 degrees Celsius, and water freezes at 32 degrees Fahrenheit, which is 0 degrees Celsius. Find the conversion equation between Fahrenheit and Celsius. And so we're going to assume that it's a linear equation, and in this case, we're given 2 points. Now, what do we have to decide? We have to decide which we'll use as our input and which we'll use as our output. In this scenario, it doesn't matter, right? You could pick either one. And so maybe before I do this, we need to pick which is our input, which is your x, and which is our output, y. In this case, it doesn't matter, right? So we just declare it, and then we move forward. So in this case, it doesn't matter. But we need to declare it. Usually what that looks like is something like this. Let x be the Celsius, maybe? Let y be the degrees Fahrenheit. You could just as easily let x be the degrees Fahrenheit and y be the degrees Celsius. Right? It'll just change the direction of your line. It'll change the slope too, and the intercept, right? So it'll change your line completely, but it would be the same as rearranging your equation, right? If x is the input, then you solve for x, right? You would get a different slope. So we're going to let x be the Celsius and y be the Fahrenheit, which really means that we're going to find an equation. So we want to find F, which is m times c plus b. Right? Kind of swapping out x and y generically for the specific F degrees Fahrenheit and c degrees Celsius. If you want to keep it as x and y, totally fine. Right? Now, we're given 2 points, and this is where it matters which one is your x and which one is your y, right? So we are given when x is 100 y is 212. And when x is 0, y is 32. What's nice about that, and using the x as our Celsius, is that now I can snag that y-intercept right away. I'll avoid it, but you are welcome to do it when you're working on your own. Okay, so our first step, right? But there's a lot of work that had to happen before we can actually go ahead and find the slope, find the intercept, which I'm hoping is feeling kind of tedious by now, almost boring. Right? No, tedious things aren't boring. It's nice because you get to feel like you know what you're doing. Well, that's how I feel. First, you find the slope. y2 minus y1 over x2 minus x1. But we did have to do all that work first. Y2 is 32 minus y1, which is 212, over 0 minus 100. (32 minus 212 is negative 180 divided by negative 100. You try that on your calculator, right? Those negatives are going to cancel. Divided by negative 100. And again, I get a nice clean 1.8. Not rounding anything, and so I find that it's easiest to just use the decimal in this case. You can use 180 over 100 or 18 over 10 or whatever version you want to use, but I'll use just 1.8. So the slope is 1.8. Now we want to find b in y equals mx plus b. Pick a point just to illustrate that it is 32. I'm going to use the first point, right? But again, if you are able to recognize that, hey, b must be 32, totally fine. Right? So I have 212 is 1.8 times 100 plus b. So b must be 212 minus 180. Feels familiar. It is. B is 32. Therefore, our generic y equals mx plus b is going to be y equals 1.8x plus 32. Or if you prefer using kind of question-specific variables, that's cool too. Y is our Fahrenheit, is 1.8 times the Celsius plus 32. If we had let x be the Fahrenheit and y be the Celsius, right, we would find what? In this equation, we can solve for c. Right? C is now the output, right? Then I would get, I'm running out of lines here. Can I do it? 1.8c plus 32. F plus F minus 32 is 1.8 C. So C must be F minus 32 divided by 1.8. Which you can clean up, but amount of space and it would be something like this. C is 1 over 1.8. Does it make anything nice? Makes 5 over 9. Let's do that instead. That's why I love this calculator. It just does it for me. And then negative 32 divided by 1.8 is negative 160 over 9. Not as nice looking, but you can do it. Okay. Nice. Any questions about kind of constructing lines? It's going to haunt us for the rest of the chapter, so it's good to get a good handle on it.
There's no let x be the f. If not, then those two answers can be the same.
Yes, they're both correct. Yeah. Yeah, so if I don't tell you what to use as your x and y, right? You tell me what you're going to use as x and y, and then I'm open to either solution. Nice. Okay. 2.2. Now, how am I doing? Before I head into this, 10:58. Okay. Okay. I wasn't sure. So I did give myself the answers already. We'll talk about them. Okay, so graphs of linear equations, like I said, all you really need to graph a line is 2 points on the line, as you've already seen when I kind of quickly sketched the line, right? You just need to plot 2 points, right? Which are what you need to find the slope anyways, and then you connect them with a straight edge, and then it extends forever, right? So graphing lines is pretty fun, but I won't make you graph lines. I think that's kind of silly, but good to know how, right? Especially for checking your answers, right? Does this make sense? Okay, so as we've already worked through, B is the vertical intercept, right? Vertical goes up and down, right? So the y-intercept, and so 0B is the point on the graph, and then M is the slope of the line, right? Which tells us how to get to the next point. Once we have at least 2 points, right, we can extend the graph of the line to the left and to the right, and then you have a line. Okay, this one got a little wonky, but the equations are here. F of x is 2x plus 1. Now, from this equation, right, this first equation, I know that my y-intercept has to be positive 1. Well, join the club, because only D has a y-intercept that's not 1, right? And so D is probably going to be the easiest one to pick out of all these equations. They all have a y-intercept of 1, except for this one, which has a y-intercept of -3. And so there, we can cross D off our list, and it matches g of x is 2x minus 3. So what's the difference between all these lines? And let's see here. Well, I gave you the answers already. I shouldn't have done that, but it's also pretty tedious. So how could you cheat your way to finding C? Or I guess finding the one with the same slope. They have the same slope. Now, we haven't introduced this yet, but we will very soon. Right? If 2 lines have the same slope, that means they'll be parallel. Right? And if they have the same y-intercept, they're the same. Right? And so in this case, right, if I'm looking at D and I know D has a slope of 2, then it looks to me, and it's hard to see here, that C runs parallel to D. Just kind of process of elimination. And so these have the same slope. What could you do? We've already worked with a graph equation, right, to find the equation. So you can find 2 points on these lines, find the slope, right? And then all the intercepts are the same except for g of x, right? And so as long as you're able to find the slope graphically, then you're okay. Right? So if we look at A, for example, A is the only line with a negative slope. And so I can pick it out of a crowd here because these all have positive slopes except for k of x. K of x has a negative slope. Right? And so that's why it maps to A. Still has a y-intercept of 1. What happens with, well, we know E and F, or I guess M of x and J of x, 1/2 x and 1/3 x. Now my rise is not very much, right? 1, and the run is 2 or 3. And so here, if my rise is 1 and my run is 2, right, that's going to look like E, versus F has the same rise but even more run, right? So it's kind of more flattened out. But just like before, if you kind of have this graph, you can pick points that are on the line, on each line. You can find the slope, right? And then that's how you would match it to the appropriate slope and intercept. We've worked with the vertical intercept, right, which is the y-intercept. We can also find the horizontal intercept, which is the x-intercept. The horizontal intercept is where the graph crosses the horizontal axis, which is your x-axis. And let me just draw a quick little. Here's your x and here's your y. The equation for the x-axis is f of x equals 0, or y equals 0. Whereas here, technically the equation for the y-axis is a line at x equals 0, right, which we know from the y-intercept. So now what we can do is we can draw a line, straight line like this, and here it'll cross. This is your horizontal intercept. You don't have a variable assigned to it, like b, for example. B is over here. When x is 0, I'm at b. So the horizontal intercept is just the x when y is 0. The x when y is 0. Oh. From here, this is what we call a vertical line, right? And then the x-axis is a horizontal line. So in general, We can talk about horizontal lines, right? Horizontal lines look like the horizon, like this, right? Straight across. And so what they'll have is some form of y equals b, right? Doesn't matter what x you put in there, it's always just going to give you an output of b. And I'm going to page here, put it here. So a horizontal line can look like this, and it can have the equation of f of x equals b or y equals b. It crosses here at 0b, and then there's no change. So the output is always b, regardless of what x is, right? It doesn't care what x is. Whereas a vertical line, right, same as the y-axis, is just a line at any x equals a. So if I draw a vertical line like this, x equals a, then here I'm at a 0. And it doesn't matter, x is always just a. And that's what it looks like. Oh. Nice. I have to find the horizontal intercept. Right, going back to here, the horizontal intercept is, we have to find the x when y is 0. Right, where does it cross the x-axis? And so here, this is asking us to find x when y is 0, right? Or f of x is 0. You can do that. If f of x, oops, wait. If f of x is 3x plus 1, then I'm solving for x when y is 0. And so f of x is 0. I'm going to replace that whole f of x with 0 and solve for the x. The x that makes that happen. So I subtract 1 from both sides, and I get 3x is -1, which means x is -1 divided by 3. And that would be my y-intercept. Or sorry, my x-intercept. I can use, I have 2 points. They're kind of hidden. Right? So now I have when x is -1 over 3, y must be 0. Right? And so we know that when x is -1 over 3, y is 0. What else do we know? What's another point we know? We know the y-intercept from the equation, right? +1. And when x is 0, y is 1. And this is from here. So again, I have 2 points. They're just kind of hidden in there. Right? A little bit of work. We already have the equation of the line. So now my goal could be to graph this thing. right? And so to graph a line, right, we still need 2 points that are on the line. So to graph a line, we need to plot 2 points on the line. And this was a comma. Connect them with a straight edge. Right. If I'm working on paper, I just use the edge of my calculator, something, anything, right? Relatively straight. You can even fold the page that you're working on over, right, and use that as your straight edge. And nothing crazy. Don't have to have a ruler. So that's why I say straight edge, not a ruler. And so connect them with a straight edge and extend the line. So if I have these 2 points, right, let's graph these. Let's graph this line. I'm not very good at making grids. Let's do this. Looks okay. -1, +1 here, maybe 2 here. Up 1. Blow it up. When x is -1/3, right, that's 1/3 into the negative, so maybe here. Then y is 0. That's where it crosses my x-axis, right? The horizontal intercept. And when x is 0, y is 1. Now I have these 2 points. I'm going to, on here I have a ruler, but I find that it doesn't like me drawing with it or on it. There. Oh, how do I get rid of my ruler? Nope. Go away. There. Nice. And there's my line. Nice. Positive slope, right? Matches what we were given earlier, right? The slope is 3, so it should be positive. If you're drawing a downward slope, then, right, you'd want to check your points. But in this case, it looks good. Okay. Gave myself a little grid already. That was nice of myself. We have to sketch these lines. These are still lines, right? Y equals 3 or f of x equals 3. And x equals 3, they're just special lines, right? We'll start with A, and I'll do it in, guess I'll do it in green. If the output is always 3, then it doesn't matter what the input is, right? And so you can start at x equals 0 and it's 3, x equals 1 and it's 3, right? X equals 2 and it's 3. You don't need to recognize these special cases of lines right away. you can kind of trial and error your way through it, right? This is saying, doesn't matter what x you give me, I will always just give you 3. Right? And the line at x equals 3 does the same thing, right? Doesn't matter what the output might be, right? X equals 3 looks like this. It's just a line at x equals 3, and x will always just be 3. So we have a horizontal line in A and a vertical line at x equals 3 in B. Nice. Oh, any questions about those two special cases? I think you could sense it was coming. Parallel lines. What's the other kind of lines that we can have? We can have parallel lines, or we can have perpendicular lines, right? And so we'll talk about what it means for two lines to be parallel, what it means for two lines to be perpendicular to each other. Okay, two lines are parallel, right? And parallel looks like this. Try to make them look like they have kind of the same. It's hard. Pretend those have the same slope, right? So parallel, they run parallel to each other. We use that all the time, next to each other, alongside each other. So two lines are parallel if the slopes are equal. And so what that looks like, right? If we have two linear equations, f of x is, and I put in a little b1, right? The first intercept plus m1x, right? First slope, and g of x is b2, just to indicate that those intercepts, those y-intercepts, are not necessarily the same. In fact, they're not usually the same. Otherwise, it's the same line, plus m2x. The lines are parallel if you can show that the slopes are the same. M1 is equal to M2. So here, if you have y equals m1x plus b1, and here you have y equals m2x plus b2, if m1 is equal to m2, the slopes or the lines are parallel. What's another way we could use this? What if I give you a line, an equation of a line, and I ask you to find the equation of a line that's parallel to it? Then you'll have the slope because they have to be the same. Right? Nice. How about perpendicular lines? Oops. Perpendicular lines are a little bit more special. See if I can. They're not that special. They're mathematically more special, I guess. Interesting, I should say. If you have a line like this, what does it mean to be perpendicular? It means they cross at a right angle, right? And so here, you might have a line that goes like this. And if I use that little right angle notation, right, that means it's 90 degrees here. Right, 90-degree angle. So then you can have y equals m1x plus b1, and you can have y equals m2x plus b2. The lines are perpendicular if you multiply m1 times m2 and you get -1. Right? Where usually what we end up using is you can rearrange and solve for the second slope, right, m2, by dividing by m1. So then m2 is -1 over m1. And so here, if m2, oops, that should be a 2, is -1 over m1, the lines are perpendicular. We also could call it the negative reciprocal of the other line slope. And we do sometimes use m1 times m2, right, equals -1. But most of the time, a question that I would ask you is I give you an equation of a line, right? And then I say find the equation of a line that's perpendicular to this line and passes through this point, right? That's another way that you could get the slope, right? And then you have a point on the line, right? And you can find the equation of that line. Okay. Now I did rejig these examples because they were kind of out of order, I thought. And so you've got the printed, yeah, I see some printed notes. We're gonna jump to this one here, which is just at the bottom of it. I kind of, you have to get your glue stick out, I guess. I also bumped the next couple of examples ahead. But first, we're gonna find the slopes that are parallel in this column and here perpendicular in the next column, in case it's not clear. We're given a bunch of slopes, and these are our first slopes, m1s. So if m1 is 2, then the slope that's parallel must also be 2, right? In fact, that's true for any of these, right? If they're parallel, then by the fact that we established, m1 is equal to m2. Right? So we're just emphasizing that. So let's tackle these parallel ones right away. m2 must be 2, m2 must be 1/2, m2 must be -1 over 3, and m2 must be 3 over 4. It's the perpendicular that's going to make us work for it. And maybe I'll use green instead, just to distinguish it. So we're forcing them to be perpendicular, which means that m2 has to be -1 over m1. Right? A little bit of work, but not too bad. And so m2 must be -1 over m1, which if I work across here, -1 over 2. How about the next one? Now I've got a fraction. And if you've got a fraction over a fraction, which we do in this case, right, then what do you have to do? You have to flip your denominator and then multiply, right? And so it's going to look like this. -1 over 1/2 is technically -1 over 1 times 2 over 1. Right? So you take that 1/2, and I have to use my fingers, and then I map them as I flip them, right? Kind of attach the 1 to the top and the 2 to the bottom, and then and then I flip them. But whatever you need to do. And of course, if you try -1 divided by bracket 1 over 2, you get -2 in your calculator, right? So don't be scared to use your calculator. It's not cheating. It's just easier. Especially if you're unsure of your fractions. For the next one, we're starting with a slope of -1 over 3, but you want to be careful with that negative, right? Because now I have m2 is -1 over -1 over 3, which is technically -1 over 1 times -3 over 1, which is -1 times -3, which is 3 over 1. So 3. So for me, eventually you will work with enough fractions that they'll just kind of work for you, right? And so all this will be just natural, right? But for me, what's most important is that you're able to find a slope if I tell you that it's perpendicular to another slope, right? How you do that, calculator or calculating it, doesn't matter to me. M2 is -1 over M1, which is 3 over 4. -1 over 1 times 4 over 3 is -4 divided by 3. This is another example that I pulled from after the next concept. So a question might look something like this. Find a line parallel to this line, y equals 3x plus 1, that passes through 0, -2. So again, we want to find a line, right? So find y equals mx plus b. We know how to do that, right? And our first step is find the slope. Right? I haven't been writing out what the steps are, right? Because we got so used to just having to calculate the slope. Now we've got this additional knowledge of, okay, well, if they're parallel, right? M1 is 3, right? Just from the first equation, I see that my slope is 3. If they're parallel, M2 must also be 3. Right? So my slope is 3. I'll highlight the parallel, because they have to have the same slope. No? Step 2, find the y-intercept. Now we're lucky. We're given the y-intercept, right? But any point that you're given, right, you do it the same way that we have been, right? What's that? That's y equals mx plus b generically, and when y is -2, x is 0, and I know my slope is 3. -2 is 3 times 0 plus b, which means that my b must be -2. Therefore, y must be 3x minus 2. That's it. It's over there, I think. So that's the equation of the line parallel to 3x plus 1. Nice. How about something that's the same with a twist? Now, find a line that's perpendicular to y equals 3x plus 1. Again, that passes through 0, -2. Notice that that's the same information, but now that it's perpendicular, it has to be a different line, right? Because 3x plus 1 looks like this, and a perpendicular line is going to look like this. Right? So, same steps, find the slope. Since they are perpendicular, we know that m2 must be -1 over m1, and m1 was 3. So m2 is -1 over 3. Now, right, again, we have the y-intercept, but let's just do the work just in case. Find the y-intercept. Y equals mx plus b. We have the point. -2 is -1 over 3 times 0 plus b. So of course b must be -2. So now our line, therefore y must be -1 over 3x minus 2. What we'll do, instead of graphing these by hand, because that sounds terrible, it's not that bad, but still. I'll plug in, first I'm going to start with the original equation in Desmos, draw that original line, right, which was 3x plus 1 for both of these. Now I'm going to check my parallel line, 3x minus 2. Looks parallel to me. And finally, I want to check that -1 over 3 times x minus 2 looks parallel, which is kind of hard to tell. Parallel to both of these lines, but the one we were working off of is the red line. It looks true. Since we did it, I'll just try to take a screenshot, bring it in. Just to check our work. But it looks good.
Does it have to be the 90 degrees?
In order to be perpendicular, yes. But 90 degrees is really hard for our eyes to see, right? When I look at this, I know it's 90 degrees because we forced it to be by forcing the slope to be -1 over the slope. But to me, I don't know about you, but for me, it looks like this is kind of any more than 90 degrees. But so my eyes don't do a good job of seeing it, but I trust that it is. So here, all right, we'll have a 90-degree angle in there. That's not very nice, is it? There. To declare it's 90. Okay. I'd say this is probably the hardest way that I could make you find an equation of a line, right? it relies on you knowing that the slope of a perpendicular line is -1 over the original slope, right? And if I give you a point, you can still find the y-intercept, even if it's not the y-intercept, you can still solve for b. And so really you follow the same procedure just over and over and over again. And for me, I would say this is probably the hardest version of that, which means, of course, I'm going to put it on the test. And I want to see what you got. But I know you got it. As long as two lines are not parallel. So the only instance where there's no intersection of two lines is if they run completely parallel. But even if the slopes are just slightly different, eventually, right, because lines continue to infinity, right, and so eventually they will intersect, right? It can take a very long time, but eventually, as long as they're not parallel, they will intersect. Now, if we think about two lines, just two lines in general here, like this, maybe I have line 1, and maybe I have line 2. So here I have y equals m1x plus b1, and here I have y equals m2x plus b2. It's two generic lines. At this point, that's the intersection. I don't usually have to, if I asked you, hey, can you guess where the intersection is? Well, it's where they intersect, right? And so here, this is the intersection. What's nice about the intersection is at this one point of xy, right? So here, this is going to map back to some x equals a, and maybe y equals b. Obviously, that's a different b from the intercepts, the y-intercepts, right? I'm just using a generic ab. Right? But at this intersection, right, both of these lines are true. Right? This point, AB, is a point that's on both of these lines. So notice the point AB is a point on both the lines. And it's the only point that's on both of the lines, right? Which means if we flip this on its head, right, at the intersection, the x has to be the same, or the x's have to be the same for both lines, and the y's have to be the same for both lines. So we're going to leverage that. So to find this point, we can solve for an x where the outputs are the same. Right? So if I force the outputs f of x to be g of x, right? I force, and I guess I should have put this y is equal to this y. I should have used f of x and g of x. That's more proper, but that's okay. You know what? No, it's not okay. F of x and g of x. There, that's more proper. Right. And I should do f of x equals g of x, which is equal to b. Right. And that's the fact that we're going to leverage. So what we do is we can set the equations equal to each other, right? If they're written in function notation like this, f of x and g of x, those are both the outputs. Well, at the intersection, they have to be the same. Right? And so, to find the intersection, of f of x and g of x, we set them equal to each other, right? Because that's a fact. We set them equal to each other. And solve for x. Right? So if I force them to be equal to each other, then I can map back and find the value of x that makes that happen. And then I can plug that value of x into either of the equations. I like to do both, right? Just to make sure I get the same value. Right? And then I have my x, y coordinate at the intersection. And solve for x. Then we use the x to solve for y. Okay. Now, in the printed notes, I'm not sure I have this one in there. So as an example, find the intersection. I do have a similar one below though. Of f of x is 2x minus 3 and g of x is 1/2 x plus 1. Let me see here. Yeah, something similar, but slightly different. This on a fresh page here. I can even write it out properly, I guess. Since I'm giving myself a fresh page here. All right. Find the intersection of these two lines. Now, what you're welcome to do is you could sketch these lines and figure out what a reasonable answer for the intersection might be, right? But we're just going to go for it. And so in terms of a first step, set f of x equal to g of x and solve for x. So if f of x is equal to g of x, and f of x is 2x minus 3, I have 2x minus 3 is equal to g of x, which is 1/2 x plus 1. Notice that I'm left with only x's. That's nice because I'm going to have to solve for x. Now, I want to collect like terms. I like to move my x's to the left and all my non-x's to the right. So let's start there. So then I have 2x minus 1/2 x is 1 plus 3. All right. So from this side, I add 3 to both sides, move it over here. And to the left, I subtract 1/2 x from both sides to move it over to the left. Here, if you collect like terms, right, your x's, then you could say, okay, 2x minus 1/2 an x makes what, 1/2 x, right? Or what else could you do? You could extract a common multiple of x outside, right? So if you want to see what you're really doing, right, then you would have x times 2 minus 1/2. But if you were able to get to the 1/2 x, this is technically what you're doing, right? You're kind of pulling out a common x multiple, and if you multiply this back in, x times 2, negative 1/2 times x, right, you get back to the same thing. On this side, a little bit easier simplification. I get 1 plus 3, and I go 4. Now, I would just suggest using your calculator for the 2 minus 1/2, right? Or what could you do? Technically, you would have to multiply by a common denominator, 2 over 2, which is 1, right? To get this, force this common denominator of 2. Then I get 2 times 2 is 4, minus 1, which is 3 divided by 2. So like I said here, x is 3 over 2, or x times 3 over 2 is 4. I would probably just encourage you to use your calculator, right? But try it, right? See how you do. X has to be 4 divided by 3 over 2. I like to write it out first before I try to get fancy with my fractions, right? Dividing two fractions, 4, I can rewrite as 4 over 1. And if you just have a number, you can always turn it into a fraction. So 4 over 1 divided by 3 over 2, and then I flip the 3 over 2 to be 2 over 3, and I multiply. So I get x is 4 times 2 over 3, technically 4 over 1, right, if you want to see it, and extend. So when x is 4 times 2, which is 8, over 1 times 3, which is 3, is 8 over 3. Anything over 3 is not usually good. No, it's not nice. So I'm going to have to keep it as 8 over 3. Be nice if it was a clean number, but that's okay. So the intersection is at x equals 8 over 3, or what, 2.66, I think it was. Repeating, 2.666666, blah, blah, blah. It's easier to think about, but let's use the 8 over 3 for our math. So we did this first part, set them equal to each other, and we solved for the x that made that happen. Now we're going to use that value of x to solve for y. So now our second step is to use x equals 8 over 3 to solve for y. Now it doesn't matter, right? You can use f of x is 2x minus 3. Or g of x, which was 1/2 x plus 1. Doesn't matter which one you use. I'll plug it into f of x. And so here, f of x, but I encourage you to try both. Maybe I should do them side by side. That's what I'll do. F of 8 over 3 is 2 times 8 over 3, then minus 3. I don't think I'm gonna get a nice number here. 8/3. 16/3, not usually. Nope. And then -3, I get 7/3. Just from my calculator. I didn't, not trying to be a hero here. So then the intersection must be at x is 8/3 and y is 7/3, right? Or it's 2.666 and 7/3 is 2.33 repeating. What if we plugged it into g of x is 1/2 x plus 1. G of 8/3 is 1/2 times 8/3 plus 1. 8/6 plus 1. Let's go for it. 8/6 plus 1. Phew, if I get the same 7/3. That's always a relief because it confirms that we actually found the intersection. And what you can do is you can check this in Desmos. I use Desmos to check my work quite a bit. Especially if you're feeling unsure, then it's nice to see it. So f of x is 2x minus 3, and g of x is 1/2 times x plus 1. And when I click it, it'll tell me what the intersection is, which is same as what we found. I'll leave the next one for review for next week. How about that? Okay. Enjoy your weekend. I know it's a ways off, but still. And I'll see you on Tuesday. Thank you.